Today we're going to talk about solids, liquids, and intermolecular forces, and how each of these forces are responsible for formation of solids and liquids. Now, have you ever seen a gecko run across a window, a glass pane, or climb across the roof of a building, or even support its own weight on one leg? And the reason for this is that it has small hairs that allows it to have great contact with the surface and allows intermolecular forces to hold the gecko in place. And we will look at how intermolecular forces impacts or solids and or liquids. Now, if you look at solids, they are tightly compact crystalline structures that are difficult to compress. They have a regularly shaped and ordered structure. Those are crystalline solids. There are also solids that are called amorphous solids, which do not have long range order. Liquids, on the other hand, are a little bit, they will take the shape of their container, but you cannot compress them. And a lot of these characteristics are because of intermolecular forces. So the types of intermolecular forces that we have are dispersion forces, dipole-dipole forces, hydrogen bonding, and ion dipole forces. Now, dispersion forces. These forces are found in all molecules, and they come about because at any point the electron in an atom is moving around the central nucleus. And as it moves, it gives a partial negative and a partial positive charge to the atom. This negative charge will be attracted to the positive charge of the other atom, and this allows the atoms to be attracted to each other and increasing dispersion forces. Now, if you look at the boiling point of group 8 elements, you notice there is an increase in boiling point as you go down the group. This is because the atoms get larger, and so they have larger intermolecular forces attracting each other. Now, long-chained molecules like and pentane, in comparison to neopentane, tend to have larger intermolecular forces. This is because the larger the molecule, the more area or surface area it has to attract each other in comparison to the smaller neopentane. Now, dipole-dipole forces occur when two molecules have permanent dipoles and are attracted to each other. This usually occurs when a highly electronegative atom is bonded to a slightly less electronegative atom. For example, in the bond between carbon and oxygen, you will see this compound having a much higher boiling point versus something such as hexane, which does not have that large difference in electronegativity. Now, hydrogen bonding occurs when the hydrogen atom is bonded to an electronegative compound such as fluorine or chlorine. It has a tendency to pull the electrons from hydrogen, creating a delta positive charge on hydrogen. Attraction between the delta positive and the delta negative charges results in a hydrogen bond. This hydrogen bond is responsible for a lot of the features that we see in water. For example, the water molecule, you would expect would have a lower boiling point than what we see at 100 degrees Celsius. The main reason for this is that there is hydrogen bonding between hydrogen and oxygen, resulting in this high boiling point.